So for 31 and 32, they want you guys to find the mistake, the error. And so if you look at this identity right here, cotangent of negative x does not equal positive cotangent x. It actually equals negative cotangent x. So right here, I'll finish it up. It says negative cotangent x. So that's a mistake on 31. For 32, there are actually two mistakes. The first one is right here. Secant of negative theta is positive secant theta. So right here should have a plus. And then the other one, sine of negative theta right here. Sine of negative theta is negative sine of theta. So there should be a negative right here. So those are the two mistakes. On 33 and 34, they did most of the verifying the identity, except they left a few blanks. So for the first one, you see that secant squared x minus 1 equals tangent squared x, straight from the Pythagorean identity. Okay, and then they finished it off by multiplying it out. 34, they converted the tangents and cotangents to sine over cosine and cosine over sine respectively. And again, by comparing this step and this step, you notice that the denominator became 1 and the numerator is a sine x squared minus cosine x squared. So the only way of doing that is if they combine the fractions together. So we're going to write on that one, common denominator is cosine x sine x. So let me change the marker here. So in this step right here, there's not enough room, so I'm going to put it here. It's going to be sine squared x minus cosine squared x over cosine x sine x over sine squared x plus cosine squared x over, I'll put it in the same order, cosine x sine x. So I added the two fractions in the numerator and the two fractions in the denominator. So then what's going to happen is sine squared x plus cosine squared x is equal to 1. And then cosine x sine x is denominator of both, so that's also going to cancel off like that. So then that's going to lead to this step right here. Oops, let me erase this. Okay, to that step right there. Okay? And so the next step is sine squared x minus cosine squared x. Notice the final answer doesn't have any more signs. So what you're going to do here is replace sine squared x with 1 minus cosine squared x. Like that. And so the final step would be to combine the cosine squared x's. Okay, 35. My goal is to get to secant x. And remember, secant x is 1 over cosine x. So as you do this, keep this in mind. Keep this in mind, because once you get here, then it's just one more step to get to the final answer, okay? I'm going to convert cotangent. I'm going to replace this with its cofunction. So I'm going to put this as tangent x and then times cosecant x. Okay? Then I'm going to convert both to sines and cosines. So sine x over cosine x for tangent, and then 1 over sine x for cosecant. Okay? So then what that does, I can cancel sine x over sine x, and that leaves me with 1 over cosine x, which is exactly this step right here. That gives me secant x. And you're done. Alright, so 36 is another problem that involves cofunctions. So I'm going to replace the numerator with sine x, denominator with cosine x, and we know sine x over cosine x is tangent x. And that's it. Alright, so this one involves the even-odd identities. So we know that the cosecant of negative x, remember cosecant is a reciprocal of sine, so that one's going to be negative cosecant of x. And then secant of negative x is a reciprocal of cosine, And so that one's going to be positive cosine of x. Sorry, take it back. Positive secant of x. Okay, so I'm going to write it as negative 1 over sine x and 1 over cosine x. And remember, every time you divide by a fraction, you're multiplying by its reciprocal. So 1 over sine x times cosine x over 1. So negative cosine x over sine x, oops, not t, is negative cotangent x. Okay? So number 38, we have a combination of even odd properties and distributive property, right? So let me first simplify the parentheses. So I'm going to put 1 plus sine y. The first one stays the same for now. The second one, sine of negative y is negative sine of y. So let me go ahead and do that. And so now I can use distributive property. So this is 1 minus sine y, oops, plus sine y minus sine squared y. So then this one and this one is 0. And you're left with 1 minus sine squared y, which is cosine squared y. Alright, for 49, I'm going to group them. I'm going to pair them up. So I'm going to pair up these two together and these two together. And my goal is to make the left side equal to 1. So the first thing I'm going to do is, in the first two terms, I notice that they both have 2 secant squared x in common. So I'm going to put 2 secant squared x as the greatest common factor, factor it out, so that leaves me with 1 minus sine squared x. The second pair, I notice they have a negative 1 in common, so I'm going to factor out a negative 1, and then I get sine squared x minus cosine squared x. Oops, sorry, plus, because I factored out a negative. Alright, so I know that this right here equals cosine squared x. So I'm going to put 2 secant squared x times cosine squared x minus 1. Now this is 1. I'm going to replace that with 1. Well, secant is 1 over cosine. So I'm going to write this as 2 times 1 over cosine squared x times cosine squared x minus 1. So cosine squared x over cosine squared x is 1. So now I have 2 minus 1, which is 1. And that's it for number 49. For 51, I'm going to convert the numerator to sine cosine. Or actually, you know that, I wouldn't even go there. I'm going to write cotangent is 1 over tangent. That's another way you could do this. Over cosine. And so we know that tangent over tangent is 1. So it's 1 over cosine. And 1 over cosine equals secant x.